All right, so the simple pantograph, let's see if I can draw it. Right. It connected down here, and it had a little square, and it had all these hinges.
And it won't like that.
Okay, and we have to pretend, at least in the beginning, all of these are straight lines. So how are we going to understand how this thing worked?
So you hold this pin down here.
Okay.
And then you put a pencil on this part. You attach a pencil to this part here.
Right.
And if you draw out a shape using this vertice, like if you draw a square, it'll draw the same shape here with the pencil, except it'll scale it 2 times larger.
Okay. Good.
I mean,
Very good.
also you can put the pencil here and trace the shape here, and it'll scale the shape down by half.
Ah, okay, so interesting. So the same pantograph does 2 times and 1/2 times, just by where you're drawing.
Yep.
Okay.
And also you can this is your hinges, you can like stretch it and bring it together. Fold it and unfold it.
That's right. You're somewhat limited. You can't stretch it all the way out to infinity, but you can, if you can draw a little shape around here, this is going to be a number. This is going to be a shape, circle like that, and this one will be double the radius. And the question is why? Why does it double?
Because, well, something to do with this this triangle made here by the vertices.
Okay, yeah. So it had something to do with this triangle.
It was using similar triangles.
Okay, and what was the triangle that was similar to this?
It was the big triangle.
Ah, the big triangle. Okay.
So they were.
Yep.
If you multiplied this triangle by 2 and all the side lengths by 2, you would get the big triangle. And
okay, yeah. So if we just said, just for simplicity, that at the beginning all these angles were right angles, and all the side lengths were just some length, equal length that we'll just call 1. What would be the length of this hypotenuse here?
root 2.
Square root of 2. And how about the length of the big hypotenuse?
That would be 2 root 2.
Okay, how can you see that?
Well, because it's another similar triangle. We've got a side of length 2 here and a side of length 2 here.
Okay.
So this whole length is root 2. Or 2 root 2, sorry. But also, you can see you've got another similar triangle that is 1 and 1. And that's hypotenuse is root 2. And then in addition to the other root 2 you already had, you have a 2 root 2.
Okay. That's a good explanation. Root 2. And so there's 2 ways to see it. We can see the 1, 1 root 2 triangle here and here. Or we can see the similar triangles. And then it's a tiny bit more complicated to draw, but not super complicated. As you move it around, these triangles will remain similar, she said.
Yeah.
So there you go. So if this length goes up some angle to here, and this point is x, or yeah, she called it in the complex plane. This point up here becomes the point 2x.
Yeah.
That's cool. And did you see it just really quickly in the beginning of the video when somebody was using the pantograph to trace like a drawing?
Yeah.
And the other pen was making the drawing even bigger.
Yeah.
Cool. All right. Now let's talk about complex numbers.
Alright.
Okay.